All right, this is an 8th grade video for section 6-4. We'll be completing page 176. But I'm going to start off with just a couple other examples that are on pages before 176. So you won't need to submit a picture of any of these problems, but on 173, we have our first problem. It says a roller coaster park is open from May to October each year. The graph shows the number of park visitors over its season. So we have the full graph here. Graph is titled Park Visitors. We have visitors on the left and we have time, months on the bottom. So our y-axis represents the amount of people, the visitors of the park, and our x-axis represents the amount of time that is passing in months. If the park is open from May through October, we're going to see here, let's see, 1, 2, 3, 4, 5. So May, June, July, August, September. Yeah, I don't know. So it kind of seems like we should probably have 6 sections. So maybe like from here to here is a month, and then from like here to here, and then maybe here to here, here to here. But we'll have like 6 different months here, but it doesn't really matter. They don't need to be exactly spaced out perfectly. But we should recognize that at the beginning of the year, at the beginning of the season, so like here's May and here's October, which right now it's October in the real world and it's actually snowing. So I'm actually going to use that as an example when we get to October. But let's see, Roller Coaster Park is open from May. So in May, at the beginning of the season, this roller coaster park doesn't have very many visitors. So like as we go up on this graph, we'll have more and more and more visitors, right? And we can see in the middle of the summer, we're going to have a lot of visitors. So I want to talk about what we see happening at 1, 2, 3, 4, and 5. So at 1, we can see this graph. This shows a period of time. So let's say some time with few visitors. There's not very many visitors here. Sorry about the handwriting there, a little sloppy, but there's not very many visitors for a little while, and it's kind of steady. It's steady. It means it's gradual. It's consistent. It's not increasing. It's not decreasing. It's a nice flat, consistent amount of guests. Okay. When we get to 2, so this is May. Maybe it's like around June, maybe end of May, start in June. We see a large increase. So I'm going to say a large increase of the amount of visitors. So what's happening in this problem is probably summer's kind of taking off. The weather's getting nice, sun's coming out, it's getting warmer, and people are kind of feeling like, hey, it's about time for us to go to this amusement park. We want to go ride some roller coasters because it's beautiful outside. Summer's kicking in, weather's getting nice. So we see a large increase in the amount of visitors. And I want to underline this word increase. It's a really important word on this problem. Our amount of visitors is increasing. And it's a large increase. It's a steep increase. Number 3, we still see an increase, but it's not as fast. So I'm going to say a slow increase of the number of visitors. Then we see from like maybe June to maybe almost August. June to August, there's still more and more and more people coming towards the end of the summer. But we get to August here, approximately August, and we see a huge drop. For number 4, we see a large decrease to the number of visitors. We see a large decrease. And what might happen in about early August, that would cause this place to start to slow down? It's probably because school's starting back up, elementary kids, middle school kids, high school kids, they're probably going back to school early August. There's still some people still going, Middle of August, there's still a pretty good amount of people. End of August, there's still a good amount of people. That's probably maybe your college kids or maybe the people who just aren't in school anymore, don't have kids. It's still kind of nice out. September, October, and then why do we see it dropping down, dropping for number 5? We see another slow, but it's decrease in the number of visitors, probably because it's getting colder again. Maybe it starts to snow like it is right now in the middle of October. I probably wouldn't want to go to a roller coaster park in the middle of a snowstorm. Maybe some of you might, but we see here towards the end of this graph, towards the end of the year, end of the season anyway, because it's only open May to October, there's fewer and fewer people that are going to this roller coaster park. So in this section, we're going to be looking at graphs, and we're going to be analyzing these graphs. And analyze means to read it, to understand it. We're going to recognize some changes. We're going to look for increases. We're going to look for decreases. We're going to look for the y-intercepts. We're going to look at the slopes. And we're going to use these as models. And we're modeling real world situations, modeling real functions. And these are functions. All of these will be functions because I know most of them it's going to be time on the bottom, because as time passes, we're going to be changing something. So let's go to the next one. We have Grace, Jet, and Mike, and they're studying 100 words for a spelling bee. We've got 3 graphs here, A, B, and C. And they've got this dotted line up in the top, which is it's their 100 words, because that's our 100. All right. Notice all these people start at 0. Okay. They all start, they don't know any of these words yet. They start, this is words learned over time in days. So I can see, just looking at these, I'm not even going to read these yet. I can see right here that whoever it is in C learns a lot of words really quick, learns a lot of words. And then towards the end of the time is learning maybe 1 or 2 words a day until they get to 100. Person B, this is your procrastinator. This is the person that puts things off until the due date, basically. I'm not going to learn. I'll maybe learn a couple, maybe a couple. Oh, wait, the spelling bee is tomorrow? Okay, I better learn 40 words. I better learn 50 words. So that's what B is doing. And person A, they're learning about 5 a day. Okay, it's a constant slope. They learn 5 words every one day, 5 words a day, 5 words a day, 5 words a day, 5 words a day, 5 words each day. Up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1. So this one's the one that's generated a plan. Every single day I'm going to learn 5 words. That's what I'm going to do. So let's read these and we're going to match these. We're going to label these graphs. This one is on page 174 if you wanted to follow along. Grace started by learning how to spell many words each day, but then learned fewer and fewer words each day. To me, that sounds like C. It sounds like this is Grace. She started learning a lot and then fewer and fewer and fewer and fewer. Okay. Her slope was huge. She learned 20 over one day, 28 over one day, or maybe not, probably not that big, but her slope's getting smaller and smaller and smaller every day. Okay. Her rise and her run is getting larger as her rise isn't really increasing as much. Jet learned how to spell the same number of words each day. So Jet goes up 5 over 1, 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 up 5 over. See, this is going to be Jet here. He's consistent. Same. This is a constant. It's a constant slope. This one's linear. If it's the same, that means it's linear. Okay. Mike started by learning how to spell only a few words each day, but then learned a lot of numbers, a greater number of words each day. So this is going to be Mike here. One thing I found kind of silly on this problem is these people didn't start. They all started at 0, and I don't think they probably should have started at 0, because I think if you're going to study 100 words, you probably know how to spell a couple of them at least at the start. So Mike, I would say Mike probably makes more sense if he looked like this. He starts somewhere here. Maybe he knows 20 or 30 of those words already. Or Grace, maybe she starts here and then does her gradual increase. Maybe Jet is a non-proportional, but he's still a straight line. I just feel like having a y-intercept of 0, having these all be starting at 0, 0, I don't think that's realistic. I bet Jet probably knew some words before he started, and Mike and Grace. That might be why Grace is learning so many so fast. She's like, oh yeah, I know how to do all these. This is super easy. And then she takes a long time to do the really hard ones. I don't know. But we've got those labeled. I don't really feel like answering more of those questions. This one down here, for this one, we're kind of going to do this backwards. We're going to sketch a graph. So Mrs. Sutton provides free math tutoring to her students every day after school. No one comes to tutoring sessions the first week of school. So let's look at this graph. We have the amount of students that are showing up as our y-axis. We have the time as our x-axis. Notice that it says nobody shows up on the first week. So I'm going to put a point. After 1 week, in the first week, nobody has shown up. So from 0 to 1, we've got just like a horizontal line here. Nobody showed up the first week of school, which makes sense. I mean, who wants to go to tutoring the first week of school? You don't even know what you're learning yet. You're just kind of just making sure you have all the right materials. Over the next 2 weeks, the use of tutoring service gradually increases. So over the next couple weeks, it's kind of increasing gradually, okay? It's a nice, pretty steady increase. So the amount of students is kind of going up, right? Over the next couple weeks. Now I want to, any of those lines, I'm just trying to make it look neater and nicer. Any of those on that blue line would be pretty good. And I'd like to keep going. So how about, so then those, let's say for the next week, that number stayed the same. Nobody new came and nobody left. And then we'll say maybe there's a test on week 5. So we have a test here, or all their work is due. This is free math tutoring. I mean, use it when you can. So in week 5, we've got lots more people showing up. They're like, uh-oh, I have a test. I'm failing. I should go and probably do all my work. Okay. And then they all get all that tutoring. They all get good grades. And then week 6, they're like, okay, we passed. Let's stop. Let's not go back to tutoring. How about that? I just kind of made up the rest of that graph. I know the one in the book had some different scenarios, but so at the beginning we had 0 kids, and then some kids showed up. So our amount of students increased, right? As time increased, and then it didn't increase. It just stayed steady, stayed gradual, constant amount of students, and then it increased really fast, a larger increase because that test was next week, and then a very large decrease from week 5 to week 6. All right, now this is on page 176. So this one here, we're going to start on this one, and this is what I want a photo of. I don't need your photo of those 3 questions. In a lab environment, colonies of bacteria follow a predictable pattern of growth. The graph shows this growth. So number 1, well, let's just look at this real quick and then we'll read number 1. We have a graph titled Bacterial Growth Curve. Phase 1, Phase 2, Phase 3, and Phase 4. We have the number of microbes, which is the number of living bacteria cells in this colony. And then this is something over time. Something's happening over time. So let's see. During Phase 2, what do we see here? We see the number of microbes increasing. Would we say it's increasing small or large, quickly or slowly? I'd say the number of microbes increases very quickly. So we see that it's going up, okay? The number is increasing over time. In a short period of time, we're starting way down here and we're going all the way up. That's a huge, fast increase of population. For number 2, what is happening during Phase 4? We can see that the population, it's going to start going down. So how would we say it begins to drop? I don't know, probably not as fast as we increased here. So let's call it, let's do drop slowly. So the population begins to drop slowly. Sound good? So we started down here. We increased to a peak during phase 3. This is a peak, like a mountain peak. Okay? We hit a peak. We had a peak on this roller coaster one at like the end of July. That was when the most people were coming. Here we had a peak on our tutoring session because it was the week of the test and everyone had to show up before they failed class. So we had a peak there as well. So I feel like that's honestly just pretty basic explanation, but probably good enough for what it's asking here. We started at the beginning of this with not very many bacteria, but if you know anything about bacteria, they can spread like crazy. They just go through mitosis and separate and break into more than one. It's all these single-celled organisms, and they do increase this rapidly. And we see something happened here that made them stop reproducing so fast, and now they're going to kind of start dying off. So I'm not really sure what happened here, but this is how we would analyze this graph. We would recognize huge increase, something slowed down that reproduction, and then they started dying off. Or they start dying off there. So I'm going to go ahead and pull up the rest of our problems here. I don't remember. Nope, I haven't copied it yet. So let's go ahead and pull this up. And here's what we'll do. All right. So we'll start here, number 3. This is a graph representing the speeds of 3 people who are riding snowmobiles. Tell which graph corresponds to each situation. So we have graph 1, graph 2, and graph 3. So let's look at graph 1. Their speed is on the left. Their speed, as it goes up, they're going faster. As we go up, we're going faster. As we go up, we're going faster over time. So let's see. Number 3. Chip begins his ride slowly, but then stops to talk to some friends. Notice stop. That's going to have a speed of 0, okay, to talk with some friends. After a few minutes, he continues his ride, gradually increasing his speed. So if we look at graph 1, graph 2, graph 3, I noticed that speed being 0 is this line here for time. And this graph 2 is the only one that has this section here in the middle where he's stopped. He has no speed. He's not even moving. Okay. So let's see if the rest of his graph makes sense. He begins to ride, he speeds up, and then he slows down because he sees his friend. He stops and talks to his friend. After a few minutes, he continues his ride and he's speeding up. At some point, he's going to settle his speed, kind of like this graph 1 did, because he's reached his max speed. But he gradually increases his speed to the end of this story. Okay. Number 4. Linda steadily increases her speed through most of her ride. Then she slows down as she nears some trees. So let's see if number 1 shows that. We do see somebody steadily increasing their speed, but then we see their speed stays the same. Okay, if we're going to slow down, well, we're going to need to go down when those trees show up. So then she slows down. Well, that's going to be right here. So this is going to be graph 3. Now I want to say, what's a story? What's a couple sentences we could write about graph 1? So we could say, Carl steadily increases his speed through most of his ride. Then he maintains a constant speed for a little while. We could just say that he maintains a constant speed for a while. So I think that covers it. Number 5, Paulo stood at the top of a diving board. He walked to the end of the board and then dove forward into the water. He plunged, that means he jumps down below the surface, then swam straight forward while underwater. Finally, he swam forward and upward to the surface of the water. Draw a graph to represent Paulo's elevation at various distances. at different distances from the edge of the pool. So, distance above the water. Where does he start? Does he start above 0 or below 0? Distance above or below water. And then the bottom of our graph is distance from the edge of pool. So let's see, where does he start? Well, he starts his y-intercept's going to be up here. This is like the top of the diving board. Okay. Then he's going to jump from the edge of the pool here. So Apollo stood at the top of the diving board. We got that one. We're done with this sentence. He walked to the end of the board. And dove forward into the water. So he's going to then jump into the water kind of like this. He's diving forward into the water, down and forward, because here's the edge of the pool. He plunged down below the surface, then swam straight forward while underwater. So it should look like that. Finally, he swam forward and upward to the surface of the water. Draw a graph to represent his elevation at different distances. I think we got it. So he starts and dives away from the wall to a point where he's going to go just kind of swim this direction. He's swimming away from the diving board still, but he's still underwater. And then he's still swimming away from the diving board, but he's going to resurface. He's going to get back up. And then I guess I threw that last step in there, which didn't actually exist. Finally, he swam forward and upward to the surface of the water. And this is where our story ends. Okay. Maybe if he was a dolphin, maybe he would like jump back out again like that and jump back in. But I don't think Apollo's a dolphin because it doesn't say anything like that. So for this section, you're going to have to use descriptions. You're going to have to tell me what's happening on these graphs. You're going to use descriptions, use words. You might need to write a pretty large description, something like maybe this large, maybe this long, and this lengthy. If you've got to cover all those steps, like I see there's 1, 2, 3, 4, maybe even 5 different parts to this story, 6 if you count his starting and his endpoint. There might be 6 different things you need to mention, okay? So this would be how you might tell a story on this kind of graph. As always, let me know if you have any questions. You have 10 questions analyzing graphs for your homework assignment this week. You can shoot me an email, you can comment on your assignments. I'd be glad to help you.